Good afternoon. This is Professor David De Los Reyes. My topic for this afternoon will still be plane areas and still under polar coordinates. Another problem which is very interesting. Okay, guys, let us start. This is now lesson number 57 on my channel on the topic Integral Calculus, lesson number 57, plane area still under polar coordinates. Okay, I will give you another exciting problem, guys. Find the area enclosed. The given polar equation is r square equal to sine of theta plus cosine of theta. The given polar equation is actually a quadratic equation. Okay. Let's proceed with the solution. Point plotting. The accurate way and how to bring out the graph of a polar equation, okay, is actually by point plotting. You complete a 360-degree angle with an increment of 30 degrees. Then solve for the corresponding values, then try to graph it on the polar coordinate system. Okay, let's proceed. First column is theta, second column is sine of theta, third column is cosine of theta, fourth column is r square, okay, and the fifth column is r, the value of the radius. So actually, we are given 5 variables here. Theta, sine of theta, cosine of theta, r square, and r. I place this value sine theta and cosine of theta plus r square for us to visualize how the polar equation behave while we are point plotting. Okay, let's proceed. When theta is 0, the value of sine of theta will be 0, the cosine of 0 will be 1, the value of r square will be 1, okay? So, if the value of r square is 1, it's a positive real number, what will come out for the rows will be a plus or minus 1. This is plus or minus 1. We are following this one, guys. When theta is 0, this will be 0, this is 1, therefore r square is equal to 1, taking the square root of both sides, therefore r now will be plus or minus 1. If we try to go to the polar, polar graph, when theta is 0, from our computation over here, the value of the radius is plus 1 and minus 1. So actually, on the angle 0, we found two points already on the resulting polar equation. The first point is this one, the second point is this one. Okay? When theta is 30 degrees, sine of 30 degrees will be 0.5. Cosine of 30 degrees will be 0.866. If we add up this one, it is 1.366. It is a positive real number. So if we take the square root, it should be a plus and minus value. The square root of 1.366, positive real number, is plus or minus 1.17. Okay, let's draw the points we found. When theta is 30 degrees, this is 30 degrees. This is 0, this is 30 degrees, right? This is 30 degrees. From our computation, when theta is 30 degrees, okay, the value of the radius is positive 1.17, it is this one. And negative 1.17, it is this one. The significance of this negative here is that if this is plus, the reverse should be minus. Okay? So this is positive 1.17, this is negative 1.17. Okay? When theta is 45 degrees, sine of 45 is 0.707, cosine of 45 degrees is still 0.707. 0.707 plus 0.707 will be 1.414. This is a positive real number. They are both positive, right? So when we take the square root, what will come out will be a plus minus value. The square root of 1.414 is actually plus or minus 1.19. Plus and minus. Okay, let's go to the graph. 0 degree, this is 45 degrees. Okay, so when theta is 45 degrees, okay, the value of the radius is actually plus 1.19. The reverse of this, try to take the reverse equivalent, okay? Just, what you call this, just extend this one going to the other line, going to the other quadrant. It is actually 225 degrees. Why 225? Because the angle of this 45 with respect to 0 is 45. So this is horizontal, this is 45. So actually, the extension of this 45 on the third quadrant is actually at 225 degrees. And the significance of the radius plus or minus 1.19, this is positive 1.19, this is negative 1.19. So actually, the graph of the given polar equation is now coming out. We got these 3 points here, and we got these 3 points. Okay, when theta is 60 degrees, sine of the 60 degrees is 0.866, and the cosine of 60 degrees is 0.5. This is positive, we add it. This is 1.366, positive real number. If we take the square root, it will be a plus minus value. So this is 60 degrees. From our computation, the square root of 1.366 is plus or minus 1.17. Okay? At 60 degrees, the first radius is plus 1.17 and the next radius is negative 1.17. It's the equivalent, or what you call this, the extension of 60 degrees on the third quadrant. And what angle is that be? It will be equal to 60. So actually 180 plus 60, actually the extension of 60 degrees on the third quadrant is 240 degrees. So opposite this 1.17, we got another radius on the 240 degree line. The value is still 1.17. Negative. Why negative? It's the reverse. Okay? If this is plus, this should be minus. Okay? So the graph now is coming out as clearly as can be seen now. Okay, let's proceed with 90 degrees. When theta is 90 degrees from the given polar equation, sine of 90 is 1 and the cosine of 90 is 0. 1 plus 0 will be 1. It's a positive plus 1. So if we try to take the square root of positive plus 1, it should be plus or minus 1. The radius at 90 degrees is plus or minus 1. This is 0 degree, this is 90 degrees, perpendicular, okay? From our calculation, at 90 degrees, the radius is plus or minus 1. So this is plus 1. The opposite will be 270, right? Below. This is minus 1. This is minus 1. This is plus 1. So actually the graph is now coming out, right guys? At 120, okay, okay, at 120, sine of 120 will be a positive value, it is 0.866. The cosine of 120, the cosine of an angle in the second quadrant will be negative 0.5. So 0.866 minus 0.5 will be positive 0.366. If we take the square root, it will become, just remove the 6 over here. So actually, the square root of 0.36 is plus or minus 0.6. So meaning, at 120 degrees, the radius of the graph is actually plus and minus 1. this is plus 1, and this is minus 1. No. Sorry guys. At 120 it is 0.6 plus 0.6, and the other one will be negative 0.6, negative 0.6. Okay? Let's go to 150. At 150, you notice this one guys. Sine of 150 will be 0.5, cosine will be negative 0.866. The negative number is greater than the positive, so what will come out for the value of r square will be a negative value, and we could not take the square root of a negative value, so it is imaginary. Also on 180, what comes out for the sine of the value of r square at 180, it is negative value, still imaginary, non-existent. Also at 210, the value of r square at 210 will be negative. If you take the square root of a negative thing, it is an imaginary thing. At 240 degrees, it's still negative, so we cannot compute for the value of r at 240 degrees. Okay, let's continue. At 270, the value of r square will still be negative, so the radius at 270 is non-existent. At 300 degrees, this is still negative because 0.866 is greater than 0.5. This is negative, this is plus. It's still imaginary. Okay, let's proceed with 330. 330 is this one. 330, where is 330? It is this one. At 330, this is negative 0.5, this is positive 0.866. What comes out is 0.366. The radius at 330 is actually 0.6, positive 0.6 and negative 0.6. This is positive 0.6 and this is negative 0.6, 330. At 360, the value of r square will be 1. You take the square root, it will be plus or minus 1. So it go back to plus 1 and minus 1. And to bring out the correct figure of the given polar equation, just interconnect all the points. Okay? It goes up here, it goes up, then you try to continue. After connecting all the points, that's the graph. So actually, the equation of this graph here is r square equal to sine of theta plus cosine of theta. Okay? If you try to see the graph, it is symmetrical with respect to the 45 degrees and with respect to the 150 and 330 degrees. So to complete the total area of the required graph, just take 1/4. Just take this area here. Okay? The first area will be from 330 to 0. This small one here, the one with the red cross hats. This one. Okay? The second area will be from 0 to 45 degrees. The next one, the bigger one. So if we try to bring out the differential area under polar is 1/2 of r squared differential theta. But r squared is actually sin theta plus cosine of theta. Okay? Right? We take the smaller 1/4 area, we multiply that by 4 to complete the total area. So differential area will be equal to 4. This is now the integral. Why 4? We got a 4 like this because actually the given figure is symmetrical. Okay? So that is with the limit from 330 to 300 degrees, 1/2 of r square. R square is sine of theta plus cosine of theta, differential theta, plus the bigger one, the limit is also 4. The limit is actually 0 to 45 degrees. Still the same equation, 1/2 of the quantity sine of theta, cosine of theta, differential theta. 4 times this, plus the smaller one, 4 times this, okay? is 1/4 area, and we multiply it by 4, okay? So this is actually 4 and this 4. Area now will be equal to 4 times 1/2 is actually 2. Easy integration, negative cosine of theta, this is sine of theta with the limit from 330 to 360. The second part, 2 times, still the same, negative cosine of theta plus sine of theta, limit from 0 to 45 degrees. A matter of substitution, 2, negative cosine of 360, we are following this, plus sine of 360 minus open quantity, negative cosine of 330 plus sine of 330 closed quantity. Okay, the first part. The second part is 2, negative cosine of 45 degrees, sine of 45 degrees minus open quantity, negative cosine of 0, the lower limit is 0, plus sine of 0. Okay guys, I didn't show you the computation of this, but if you try to use your calculator, what comes out for the first one is 0.732. For the second one will be 2. So the total area bounded by the given equation r squared equal to sine theta plus cosine of theta is actually 2.732 square units. That's it guys. The number one procedure, you use point plotting. It's a very long, tedious steps, but it will show you how accurate the figure, the graph that will come out. So actually, you start from 0 up to 360, plot all the points, then interconnect all the points so you could visualize what will be the graph of the equation r squared equal to sine of theta plus cosine of theta. Then, on the integration, it's not so hard. Actually, the hard part is actually the point plotting. Because if you are not accurate in the computation of the value of sine of theta and cosine of theta, you will make the mistake on the r square. So obviously, the value, the resulting r will be a wrong one. So if you are correct on the r square, what will come out for the r will be a correct one also. And actually, for the r square, just consider the positive real values. Because if the value of r square is positive, the radius will be plus or minus. If the value of r square are negative, the sign of the overall value is negative, there will not be a radius coming out from those angles. Okay? Actually, it is 6. 1, 2, 3, 4, 5, 6. That is from 150 to 300. The radius from those angles are actually imaginary. But as we go from 330, the points the radius are again coming out. It's plus 0.6 and plus or minus 1. So actually, we got a good graph by using point plotting. Okay guys, good afternoon, Los Angeles.